Okay, so recording. So we'll start the next chapter. See, the chapter is general principles and processes of isolation of elements, isn't it? So you learned in 10th about the basics of that. What do you mean by isolation of elements from means the how do you get metals? It is in this chapter basically metals. How do you get metals from the ores? So the terms which you already learned in 10th standard, I will just tell you. So what is the difference between minerals, or what is a mineral? Minerals are, see, the metals are present. Metals are reactive normally, isn't it? Except gold, silver. Normally the metals are, since they are reactive, they will be present in the earth's crust in the form of compounds, isn't it? So metals are present. As such, metal alone, the metal, pure metal alone we don't get. The metal will be in the form of compounds. And so the compounds of metals are found on Earth's crust or in the earth. They are called minerals. All of you agree? So the metals are present in the form of minerals. That will be compounds of metals. So from the compounds of metals, we have to isolate metal. That is the full process is metallurgy. All of you understood? And so normally, so what is the difference? You learned in 10th standard. Then what is ore? What is the difference between ore and minerals? Tell me.
Ma'am, ore, the major component of ore will be the pure metals, ma'am. But
No,
minerals, there can only be a small.
no, not that. Anybody else remembers?
Ma'am, in ore, the metal is concentrated, while in a mineral, the metals are in a disproportionate amount.
No. Any other answer?
I mean, ore there are impurities also with
Isha.
with the metal there are impurities also.
What? I can't hear. Say once more.
Ma'am, the ores, no, ma'am. With the metal there are some impurities also.
I didn't hear. Vishnu Priya, Varsha. Ruchi, any answer?
Ma'am, when we find the metals in the earth soil, ma'am, as then they'll be called as ores along with minerals.
No, then what are minerals then?
Ma'am, minerals are naturally occurring.
Okay, then ores are not naturally occurring?
Yes, ma'am, but ore contain minerals.
Contains?
Minerals?
No, not that. So these are not the answer. I will tell you the answer. See, I will say with an example. So aluminium. No, ores contain metals. Minerals also contain metals. So I will tell an example. When the question comes, what is the difference between ores and minerals? You remember this example. See, aluminium is a metal, isn't it? And it is present in Earth's crust. In clay, it is present. In bauxite, the ore of aluminium is bauxite. Have you heard about bauxite? So aluminium is present in clay also, in bauxite also. So bauxite is the ore of aluminium, not clay, because the minerals and ores both contain the metals. But from all the minerals are the compounds which somebody said, naturally occurring compounds of the metal present in Earth's crust. Even ores are also naturally occurring only. The difference is that we cannot get the metal from all the minerals profitably and economically. Okay, so those minerals from which we can extract the metal profitably, they are called ores. So from clay also we can get, but then the process is complex or it is costly. So we don't take from clay, we take from bauxite. because we can easily get aluminium from bauxite. Both are minerals. Clay is also a mineral of aluminium. Bauxite is also a mineral of aluminium. But we can get aluminium profitably from bauxite. That is the difference. All of you understood? So you write down certain...
Ma'am, does profitably means that ores have a does if you said that profitably it can be extracted, ma'am, so does it mean that ores have more of like the
No,
metal?
no. Not that.
Okay, so
Low
minerals
cost. One
have
is
the
low
same.
cost. Profitably means one is low cost. Second one is you will get good yield. So all this. So after anyway, these are processes. They are expensive. After doing that, we are not getting enough aluminium or more costly. That is profitably, economically. Okay. So write down certain things. I will tell you. Write down all of you. So you say the minerals. Minerals, what is somebody said that is the minerals are naturally occurring compounds of metals present in the earth crust, or naturally occurring minerals are naturally occurring compounds of metals present naturally occurring compounds of metals present in Earth's crust. Written? Now, ores. The minerals, ores definition, the minerals from which we can extract metals economically. Minerals from which we can extract metals economically are called ores. We can extract metals economically are called ores. Done? Agnel, are you present? Why Agnel is moving in between?
Yes, ma'am.
Ma'am, can you repeat the definition of minerals?
Which sentence?
Minerals.
Minerals, naturally occurring compounds of metals present in Earth's crust.
Okay, ma'am, got it. Thank you.
So ores are the minerals from which we can extract metal economically. They are called ores. Clear now? Now you can take the book. So table 6.1, all of you take table 6.1. The principal ores. Now see, we don't say minerals because we get metals from ores. Okay. So the table you see and go through the table, because one more question they may ask you. For example, bauxite is an ore of which metal? So you should have some idea. Okay. So you see iron, hematite, magnetite, siderite. These are all, you should know that these are ores of iron, that way. Okay. And copper, copper pyrite, malachite, cuprite, zinc. See calamine. Calamine is, see, they can ask you even for competitive exam. Which one of the following is calamine? Calamine is the zinc carbonate. Clay is not an ore. Bauxite is the ore of, see, you see the principal ores of some important metals. This is the second one is a form of clay. That not the ordinary clay. Okay, Palak? So you see that the calamine is zinc carbonate. In competitive exam and all, they ask zincite is zinc oxide. So that table, you go through the table and learn. Okay. So that is, so you now we are going to the principles. Okay. Now you know, so you get metals from, we get metals from the ores. Now, what is metallurgy? The process of extracting the metal from the ore is called metallurgy, right? The process of extracting the metal from the ore is called metallurgy. All of you write down that sentence. The process of extracting the metal from the ore is called metallurgy. So we are going to learn metallurgy in this chapter. Okay?
Okay, ma'am.
Agnel, where you are going in between? Switch on the mic,
No, ma'am, I'm
Agnel.
here
Don't
only.
say net issues.
I'm here only.
No, you
I'm
left
present,
and
ma'am.
now only joined. Where you are going in
No, I was
between?
present from the beginning.
Hmm?
I
Then
was
who
present from
one
the
student
beginning
is
only.
not there? Who is that?
I don't know, ma'am.
No, you left, it came some time back. You were there.
Abhishek is not there, ma'am.
Abhishek hasn't come. He joined and he left. Abhishek, first he was there. Attendance was there. He joined and left. Abhishek, come to the class. Okay. So metallurgy is the process of extracting the metal from the ore. Okay. So there are basically three processes. For first one is, you write the first process, purification of the ore. Right. Purification of the ore.
Ma'am, can you
Have you
please
written?
repeat? Your voice was breaking.
There are three processes. Can you hear me now?
Yes, ma'am.
There are three processes. Chinmaya, can you hear me?
Yes, ma'am.
There are three processes. One, purification of the ore. Write that. Purification of the ore.
Ma'am, three processes that is included in metallurgy.
Metallurgy. How do you extract? There are three processes. One is purification of the ore. Written? Why I said to write, there are three names. Okay? Bracket. Purification of the ore concentration. Right, ore concentration. Another name is ore dressing. Ore dressing. Another name is benefaction. So that is the question. BENEFACTION. So once they asked, explain the following terms, benefaction. So you understood why I said or dressing or concentration or benefaction. These are all the same. It is purification of the ore because we are getting from the earth's crust. It will be filled, the ore will be containing lot of impurities. So the first step, we have to remove impurities from the ore. That is ore concentration. Okay, concentration of the ore. If they ask any of this term, what is benefaction? It is the purification of the ore. And so after benefaction, we will get ore only, but that will be pure ore, not the metal. Understood? Now, second process, conversion of the ore to metal. Conversion of ore to metal. That is second process. Third process, purification of the metal. Okay? So, three processes are there. Clear this much? So, from ore, first we will purify the ore. That is concentration of the ore. After purification, you convert the ore to metal. So, we get metal that is impure. And the third process is purification of the metal. Clear? Then some terms we see in metallurgy. The impurities we call, anybody remembers? You learned in 10th. Impurities are called?
Ma'am, is it gang?
Is it?
Gang.
Very good. Gang. Palak and Kirtana. Is it Kirtana? Good.
Yes,
So
ma'am.
gang. The first term is gang. GANGUE. Gang. Gangue is the impurities present in the ore. Okay, so first term gangue. Written? Impurities present in the ore. Now the next term is flux. What is flux? Flux.
Substance added to the ore to separate gang and the.
Ma'am, this is under which topic, ma'am? This gang flux and all.
What is that? What, Anand?
This.
What are you asking, Anand?
Amitabh.
Amitav is asking what?
Ma'am, this gang and flux is under which topic, ma'am?
Flux are?
Under which topic, ma'am, these are?
Not able to hear.
Ma'am, this gang and flux are under basically which topic, ma'am? I was just noting down, so.
No, some terms you will come across. So you should be knowing. In terms,
okay, ma'am,
you say some terms in metallurgy. Okay?
Fine, ma'am.
Gangue is the impurity. Now onwards, we don't say impurity, we say gangue. Then you should be knowing. And what is a flux? Amita was saying, Anand was saying, what is a flux? A substance?
Substance added to the ore to separate the impurities and the.
Very good. Substance added to remove impurity is called flux, right? Good, Palak. So, substance added to remove gangue is flux. Written? Now, the next term is slag, S-L-A-G, slag. When flux reacts with gangue, slag is formed. Slag, S-L-A-G. So, what is slag? Flux plus gangue. When flux reacts with gangue, slag is formed. Written? Flux reacts with gangue, slag is formed. Clear?
Yes, ma'am.
Yes, ma'am.
Okay. Now we will go to the first process. What is the first process? Say first. What is the first process? Purification of the ore. So, heading. Concentration of the ore. Now, this you don't have to write. This given in the book. I will tell you. If at all it is difficult in the book, then I will give in simple sentence also. So, the different methods of ore concentration. That means for purifying the ore, different methods are there. So the first one is gravity method. So here the question, see, gravity method is used when there is a difference between the gravities of the ore and the impurity. Gravity means density. Suppose the ore particles are heavier and impurities are lighter, then we use. If you want, I will give you notes. If you can write down fast. You want, or you will learn from the book?
You can give notes.
Say?
You can give notes, ma'am. It's all right.
Okay, so gravity method. So first I will explain, then in short I will give you the notes, okay? So you listen first. Gravity method is normally used for oxides. So that will be the question. Sometimes they say iron oxide. Hey, hematite is an ore of iron. How do you concentrate hematite? Like that they ask. So you should be knowing hematite is an oxide ore. So oxides are normally concentrated by gravity methods. Okay. So I told you the difference. See, the ore particles are heavier, and that is gravity, isn't it? Difference in the density. And the impurities are lighter. Then we use this method. The method is very easy. You will keep the ore on a sloping floor, on top of a sloping floor, and then you will wash with an upward stream of water. So what happens? Lighter impurities will be washed away, the heavier ore particles will be left. That is the method. You will be washing with water. So here the method is impurities are lighter and the ore particles are heavier, isn't it? So the lighter impurities are washed away. Have you understood? Now, any doubt?
And what do you mean by upward stream here?
Upward stream, I said, no, the ore will be slope, you know that. Now, there will be a floor and down there will be a slope. So on top of the floor, you will keep the impure ore. And so from upward stream, they are saying you will see with force, you will put the water. So the impurities will be washed away and the ore, heavier ore particles will remain on the floor. That is it. Okay.
Okay, I'm understood.
Now write. So I will say what to write. Because of the based on the nature of the questions. Okay, I am giving. So you say gravity method. Oxide ores are purified by this method. That is the first point. So if the question they ask, I said now once they asked hematite is concentrated by which method, so you will get an idea. The table is there, you know, the some idea about the composition, isn't it? So first thing is oxide ores are concentrated normally. Oxide ores are concentrated by this method. Written? Now, principle, suppose they ask you. So this method is based on the difference in gravities of ores and impurities. This method is based on the difference in gravities of the ore and impurities.
Difference in
Gravities. I said heavier. Ore will be heavier and impurity will be lighter. Difference in gravities. That is the meaning, but the term we are using the same word term they have given in the book. All of you understood? Difference in gravities. Okay? So you say the next sentence. The ore is washed with an upward stream of running water. The powdered, everywhere powdered you have to use. If I told, I don't say. The powdered ore is washed with an upward stream of water. Okay. The lighter impurities are washed away. The lighter impurities are washed away, leaving behind the heavier ore particles. Lighter impurities are washed away, leaving behind the heavier ore particles. Got it? Okay, done?
Yes, ma'am.
Now, see, you have to learn, okay? It is not very difficult. And this is theory. I can ask you. Tomorrow question answers will be there. I will be asking questions. Okay? So, next method is magnetic method. Okay, so magnetic method, first I will explain, then I will tell you the important points. This method is used if either the ore or the impurity, any one is magnetic, then we can use this method. Okay, and so hematite ore. Hematite, you know that hematite is magnetic, iron is magnetic, isn't it? And suppose the impurity is also magnetic, we cannot use. Then if the impurity is non-magnetic, we can use. Okay, so the method is that what we do, we will take an electromagnet, a magnet we will take, and then another roller you will take, and then a belt will be passed over this. I will draw a quick diagram. This is the magnet, okay? And I have to pass a belt. So this is another one, and it is not magnetic. So this is a conveyor belt. In polymer, somebody was asking, now what is a conveyor belt? So this is another roller, and the belt will be moving over these two. Out of that, this is a magnet. Okay? And now I will be putting powdered ore over this belt. Powdered ore. So I am putting powdered ore, which is impure. Out of that, Either the ore or impurity is magnetic. So when I put over this is moving. This conveyor belt is moving. I said in an airport you see the luggage when it comes, there will be a belt moving. So when the powdered ore is dropped over the moving belt, the conveyor belt, and when the ore is coming near the magnet, the magnetic part will form, and here it will be, the magnetic part will come near the magnet. So this is the magnetic part, and the non-magnetic part will thrown away from the magnet. So you will come, the magnetic part will come as a heap near the magnet. So you separate it, impurities from the ore. Have you understood?
Ma'am,
Hmm.
for that we should know, no, ma'am, whether the impurity is magnetic or the metal.
We know that. So normally in the ore, what are the impurities present? We have some idea. Okay. So such cases we use. The method all of you understood? Yes, Anand.
Ma'am, this method seems to be a bit inefficient, ma'am.
No, it is used. This method is used. So
Because the magnetic, if the impurities are magnetic, like if the velocity is too much, they might go into the ore itself, right?
no. This is a strong magnet. So that will be thrown away from the magnet. Only the magnetic part will be near the magnet. So you will get two separate heaps. One heap of magnetic and another of
If this
non-magnetic.
magnet is strong, then isn't there a chance that some particles of the ore that is constant, that is pure,
No,
ma'am, that will stick
non-magnetic
to it?
part will not come. These
No, ma'am,
are methods.
the magnetic part, isn't there a chance that it won't fall and it'll just stick there, like some particles?
No,
In
no,
that
no,
case,
no,
ma'am,
no.
we are losing some materials.
No, the belt is moving. It will be thrown away. You see the diagram. It will be collected as two different heaps. The book, you see the diagram? These are all methods, approved methods. Okay?
Fine, ma'am.
Okay. So you write the note. I will give you the note. This is based on meeting. What meeting? Okay. So this is based on difference in the magnetic properties of the ore particle if the either. Okay, you write. This method is used. This method is used if
Ma'am, what was that? This method is based on the first line you gave.
no, you write. This method is used if either the ore or the impurities. This method is used if either the ore or the impurities are magnetic. Either the ore or the impurities are magnetic. So, written the powdered ore is dropped over a conveyor belt. The powdered ore is dropped over a conveyor belt which moves over a magnetic roller. The powdered ore is dropped over a conveyor belt which moves over a magnetic roller. Next sentence. The magnetic part will be collected as a separate heap. Magnetic part will be collected as a separate heap near the magnet. And the non-magnetic part will be collected separately away from the magnet. Will be collected separately away from the magnet.
Ma'am, could you repeat that part? The magnetic part will be collected as a separate heap.
Heap near the magnet. Okay.
The last part, the non-magnetic part will be
Collected separately away from the magnet. Okay. Done? Written? Okay. Okay. So next method is froth flotation process. In this question, in this many questions are there. Froth flotation process. Okay. So here first point is sulfide ores. Sulfide ores are concentrated by froth flotation process. Okay. I will explain the process and then the questions, coming to questions. Mostly one question you can expect from this froth flotation process. I'll tell you what it is. Okay. What we do is that first I will tell you the process. You will everything you have to powder the ore. So you powder the ore and mix with, you learned in 10th, isn't it? Have you learned this method, froth flotation process? Have you learned? No. Okay. So froth flotation process, first thing come to your mind is it is used for purifying sulfide ores. Okay. Now what we will do, we have to, the steps, I will first say what we do. We have to powder the ore and make a suspension of the powdered ore in water, and then you put it in a vessel, powdered ore in water, and then you have to add pine oil, which is called collector. So we have to add collectors. So one example is pine oil, and another or fatty acid or xanthate. You have to learn by heart. Okay, 3 collectors. Any one collector you add. Normally we add pine oil. Okay. So make a suspension of powdered ore in water, add a collector. Collectors can be pine oil, fatty acid, or pine oil, fatty acid, or xanthate, anyone. So I put pine oil, that is the collector, and a froth stabilizer. So,
ma'am, the collectors can be pine oil, fatty acids, and
no, I will give you notes. No? It is there in the book. It can be a xanthate, a compound called xanthate. Okay, you just listen now. So, powdered ore in water, add a collector and a stabilizing, froth stabilizer that you add. And then you have to rotate the mixture with a rotating paddle. So rotating paddle, you will keep stirring, and when you stir, air also will get into it. So you are stirring properly. Then what happens? The ore particle, we are using this method to purify the ore. The ore particles will come along with the oil and as a froth on top. And impurities will be remaining in the solution in water. Ore
Ma'am,
particle,
can you repeat this thing again? I didn't understand properly.
see, you powder the ore and make a suspension of water or add water, powdered ore, water, take in a vessel and add collector and stabilizer, froth stabilizer, and then you have to stir it using a rotating paddle. When you stir using a rotating paddle, air also comes. These are the points. So when you stir, agitate, you have to, it is not with the hand, the mechanical. Rotating paddle, when you agitate, what happens? The ore particle alone will come on top along with the pine oil. Pine oil carries the ore particles and the impurities will go into water. Okay. So the froth contains pure ore particles, and that who is carrying, that is the role of collector. Okay, the pine oil is carrying pine oil along with ore particle come as a froth on top. The froth can be skimmed off. You can remove the froth that carries the ore particles. Impurities will be in water. Now, okay. So what
yeah,
you do, you take a vessel, add powdered ore, add water, make a suspension, add collector, and you have to add the collector and the froth stabilizer. You have to add collector and froth stabilizer. Then you will agitate the mixture with a rotating paddle. When agitate means it is a mechanical one, it will be keep rotating or you are stirring. And then when you stir that, use that rotating paddle, air also will get into it. Okay. Then what happens? The ore particle, froth stabilizer, froth will be, it will come as a froth. Na? So it will stabilize that. To stabilize the froth, we add froth stabilizer. So on top, you will get the froth containing the ore particles that you can remove. Impurities will go to water. Understood the process, all of you?
Yes, ma'am.
So the
Yeah, ma'am.
questions they give when you get the frequently asked question is the principle of froth flotation process. The principle is that the so the principle is that the ore particles, when you do this, the ore particles are wetted by the pine oil and the impurities are wetted by water. That is the principle. That is why the ore particles are coming to, the ore particles will go only with the pine oil. So that is the principle. So there is a sentence, the mineral particles, now don't say mineral, the ore particles become wet by oils and the gangue particles by water. That is the principle. All of you understood? Now the next question they say, what is the role of collector? What is the role of, this is the next frequently asked question. What is the role of collector? Give an example of a collector or give 2 examples of collector. Okay. So now collector is the pine oil. What is its role in the, I said, no, the ore particles are wetted by oil, isn't it? So the role of collector is it will increase the non-wettability. That means that non-wettability, it will increase the non-wettability of ore particles. That is the sentence. That means the ore particles will not go to water. There the wettability means wetting is with water. That is the meaning. Okay. So you will write the same sentence. All of you understood. It will enhance.
No, ma'am. Can you explain that again, please?
See, the principle is the ore particle will go to oil and come as a froth and you will be collecting, isn't it? So the role of collector is it will increase the non-wettability. That is the sentence. It will increase the non-wettability of the ore particle. What is the meaning? The ore particles cannot be wetted by water. So the pine oil will take it. So it will increase the non-wettability of the ore particle. There the wettability is wettability of the ore particle in water. Understood? Have you understood, children? Clear?
Understood, ma'am.
Yes, ma'am.
So that is the second question. Now the third question they ask is, which Naomi asked, what is froth stabilizer? Froth stabilizer, what is the role of froth stabilizer? Give an example or 2 examples. So examples given cresol and aniline. You have to learn by heart. What is the role? It stabilizes the froth. It is easy. Froth stabilizer stabilizes the froth. That is the third question. Okay. Fourth question they ask, suppose the ore is a mixture of 2 sulfide ore. Okay, suppose zinc sulfide and lead sulfide both are there. Some mixture, suppose mixture of zinc sulfide and lead sulfide, and I want only lead sulfide. Okay, so I want only lead sulfide. So I will add this depressant. Depressant is sodium cyanide. So if I add sodium cyanide, only lead sulfide will come to the froth. Zinc sulfide will not come. So I can separate the 2 sulfide ores by adding a depressant. Okay, so that question, what is the role of depressant in froth flotation process? These are the questions. And then of course the process. that is less frequently asked. The more frequently asked question, principal. Depressant, very, very frequently. Depressant. What is the role of depressant? If two sulfide ores are there, depressant will allow only one sulfide ore to come to the froth. And example of a depressant, sodium cyanide. Example of a collector, you have to learn the three examples: pine oil, fatty acid, xanthate. Diagram, if they ask you the process that is less frequently. See children, we don't have, see even if 2 and 3 mark, you don't get one question as a 2-mark question. So that possibility is very less, but they can ask. Okay. So,
what is the use of depressant?
Depressant, suppose two ores are there, two mixture. Suppose I am going to extract lead, but the lead sulfide ore is having zinc sulfide also. So two sulfide ores are there. Then the depressant will allow only one sulfide ore to come to the froth. Accordingly, we will put the depressant. Example they have given. Suppose lead sulfide and zinc sulfide are there. If you add sodium cyanide, then only lead sulfide will come to the froth. So I separated the sulfide ores.
Can we make lead sulfate to come to the top?
If we add that example given in the book is that sodium cyanide, if you add, then zinc sulfide will not come to the froth.
And then how to make zinc
sulfide? No, this is a one particular example. So normally in the case of zinc blend and all, there will not be any ore present. If there is a then suitable depressant, you have to add. Okay.
Every separate ore there's a.
Now, if there is a mixture, now if there is nothing, then no need. Okay. So that is froth flotation process. So you write froth flotation. You understood the type of question. So many questions from this small topic. That is why it is taking a lot of time. Okay. Now you write froth flotation process. Sulfide ores are concentrated by this method. Sulfide ores are concentrated by this method. Okay. Now procedure. Make a suspension of the powdered ore in water. Make a suspension of the powdered ore in water. Okay. Add collectors. Add a collector. Bracket 3 collectors name. Pine oil. Anyone you can put. Add a collector. Bracket pine oil, fatty acid, and xanthate. Bracket close. And froth stabilizer. And a froth stabilizer. Bracket aniline cresol. Froth stabilizer. Okay. Now you will say collector will enhance. That is the role of collector. That is very important. Collector will enhance the non-wettability of the ore particles. Collectors will enhance the non-wettability of the ore particles. Froth stabilizer will stabilize the froth. Froth stabilizer will stabilize the froth. Written? Next sentence. The mixture is kept agitated. The mixture is kept agitated by a rotating paddle. Kept agitated by a rotating paddle which brings in air. Agitated means stirring. That only. That means stirring vigorously. That is why agitated word is used. Stirring vigorously. So you don't write. You write that the mixture is kept agitated by a rotating paddle which brings air in. Which brings air in. Next sentence. The pine oil carries the ore particles. The pine oil carries the ore particles and comes on top as a froth. Comes on top as a froth.
And the pine oil?
Carries the ore particles. Carries the ore particles and comes on top as a froth, which can be skimmed off. Which can be skimmed off. The pine oil carries the ore particles and comes on top as a froth, which can be skimmed off. Okay, Prashant? Written? The impurities will go to water. The impurities will go to water. Okay, next one more sentence. Depressants are added. Depressants are added when we want to separate two sulfide ores. Depressants are added when we want to separate two sulfide ores. Example, sodium cyanide is added. If sodium cyanide is added, NaCN is added to a mixture of zinc sulfide and lead sulfide. If NaCN is added to a mixture of zinc sulfide and lead sulfide, it will allow only lead sulfide to go to the froth. It will allow only lead sulfide to go to the froth.
Ma'am, mixture of zinc sulfide
and lead sulfide, comma, it will allow only lead sulfide to go to the froth. It will allow only lead sulfide to go to the froth.